This conference will now be recorded.
So in the last session, we were trying to understand on how deployment will be happening, right? So in that, we were understanding different strategies that we have in Kubernetes. Among them, the first one that we saw was recreate, where recreate is all about when you have existing deployment, or let's say an object which is already available. In recreate, the current version will be terminated and you'll be just creating or replacing it with a new version. This is what we did, okay? And we just recreate. Now, this is more suitable for development environment because the issue is there will be a downtime where you are stopping all your current version and then replacing it with new one. However, now let's look into the other type, which is called as rolling update. Okay. Now, before we go, just have a definition. Now, when I say rolling update, what we are going to do is the second version is slowly replaced with the first version. So rather than stopping everything, it is going to make sure first your newer version is up, and only when that is up, the previous or the older version will be shut down. Okay. Now, how does that happen? Just watch this. So assume the same deployment object where we have, and there is a service which is being used, and the deployment object has two replicas. Now, in a rolling update, what happens is you don't just shut down everything. First, you try to create a new replica which would be based on the image that you have on the latest. Okay, so again, going back to the example what we have yesterday. So I took Nginx 1.10, which was running earlier, and assume that now I want to replace that with the new build image of the version 1.11. So then when I update the same object to use the new image of Nginx 1.11 build, then the same two replicas, then what Kubernetes will do in a rolling update is first it will create one new replica which will be based on Nginx 1.11, which is the second build. Okay, and when the first new pod comes, then what it will do, it will try to replace the old pod with the new pod, that is the first old pod with the first new pod, and then it deletes it. And the same way, now you can see we have one new pod and another replica is still old. So that way it will take one by one and it will be replacing the replicas with new replicas, where the new replica will be pointing based on the image or the spec of the object which you have applied. And once this new pod comes up, then the old pod or the old replica will be replaced. Okay, so this is where when you still access the service, you will be now able to access the service. So rolling update means it doesn't replace everything together. Slowly, it will be trying to update one replica at a time, and then it will be replacing all the replicas that you have in your object one by one. Okay, so this method is what we call it as rolling update. Now, the advantage, if you see here, you're going to typically release the product version whatever you have one by one. Okay, because internally if you take a deployment and what does it do, a replica set, right? So you might have everything together, but it will be just replacing one by one with the old replicas with the new replicas of the definition what you have given. Okay, now the disadvantages that you take here, the process of complete rollout or the complete deployment will take a lot of time. That's because if I have 10 replicas, then typically you need to wait until all the replicas are up, because when the first replica gets replaced, it waits until that replica has the container started fully. Only then the second replica will get replaced, right? So that way it's kind of slow. And the next thing what we have is we do not have a control over the traffic. So assume you are the customer and now you are accessing the first replica in the old pod or in the old build. Now suddenly, again as a customer you are trying to access, where should the traffic go? Whether the traffic should go to the old replica or should it go to the new replica, right? So again, this will be somewhat an issue to manage the traffic. Okay, so that's when these kind of deployments are more suitable, where you don't have to worry about the traffic or the access. That's where typically this is more suitable for a product which will be a stateful application. Okay, because going back, a stateless application cannot work in this way. Why? In a state, okay, sorry, I was telling the reverse. So it's more, yeah, it's more convenient only for a stateful application where you're trying to take up everything one by one, right? Rather than replacing everything together, it kind of does in sequence or in order. But more preferably for QA and staging environment. Okay, so if you go to production, this is something which will not be suitable, because in production, if you do one by one and it's going to be very slow, so typically your production downtime will also be increasing. Okay, and now in production, if it is a stateful application, then you might be going with a rolling update, so that is fine. But typically for a stateless application, we will not be using this on the production. More of QA stage is what we are going to do. And this type is the default type of deployment. That means so far, whatever we have learned, right, we never introduced a new keyword called a strategy for deployment. So that way, the default strategy which Kubernetes follows is a rolling update. So that is how whatever that we were doing, we were working on the rolling update. Okay, so remember, all this time, whatever that we were doing some changes and applying, it was working in a rolling update fashion. So this is the default strategy which Kubernetes will be using. Now, let's take an example of what we had earlier, right? And we'll try to see how it works. Now, so we'll go to our changes. Okay, let me. Okay, let's take this build one. Okay, so I'm going back to the same definition where we have the build one.yaml, and here you can see I'm specifying nginx 1.10, and over here I'm just trying to create a deployment with 2 replicas. Okay, so let's just apply kubectl, apply build one, and I'll also apply the service. So these 2 things I've just applied. So here you can see that there's a deployment object, a replica set, and accordingly there are 2 parts, and there is a service which is available. Okay, now if you try to check, right, so what we will do, Now, if I say curl -s and if I take the nginx, okay, or let's take HTTP, okay, I can take the IP and version. So this is 1.10. Is it okay, or do you want me to increase the font? Is it visible for everyone?
Yeah, yeah, yes. Yeah, you
Is
can
it fine, or
increase
do you
little
want to
bit,
increase?
Anand. Little bit.
Okay.
Yeah. Thank you.
So I didn't do any changes. So all I did is we applied, right? Now, what we will do is I'll copy this build1.yaml, okay, with, I'll just say, okay, let's say build1 rolling update.yaml. So let's open this. Now here, all I'm going to do is I'll be just removing the strategy, okay? So that, okay, actually I don't have any strategy, but if you had looked here in the build2.yaml, now yesterday we had defined it as strategy and the type recreate, correct? Now, if I just remove this, then this becomes default strategy, which is a rolling update. So I can typically just go ahead and change this itself. Now here, it's the same definition of my build one YAML, but the only change is now here, instead of the image one, we will say it's going to be image two. Okay, so that is what we are going to say. It's not image one, but nginx second image, which is 1.11. Okay, so this is the change what I'm trying to give. Now we'll do one thing. We'll make this as 3 replicas just to see. Okay, so if you look at the difference, okay, so these are the only two differences. Okay, now here, so here, let me go ahead and say watch and kubectl get all. Okay, so this is what it is. Now to understand the rolling update, let me just go ahead and now execute kubectl apply -f build2.yaml. So here you can see I have taken the same object name, same label, but the only change that I have done now is updating with the new image and the replica. But however, in that, what we have told, we have mentioned that I need to do the default update, which is rolling update, right? You can see when the previous one are still running, so it's trying to create one by one, and accordingly it replaces the new pod. Okay, so that once the old replica is being removed, then it'll just go ahead with the next one, and when the second new pod comes up or the replica comes up, the old replica corresponding it to it will be removed. Okay, so that is what we call it as rolling update. Now let me just show you once again. Probably I'll now apply build one once again. Okay, just to show you. So watch it. So it takes one and it's running, and then it takes up the other one. Okay, so this way now as an end user, now okay, let me apply build two once again. You can see it takes one by one. Okay, so this is how the default way what we do in Kubernetes is a rolling update, where it's going to take one replica at a time and it's going to replace the new one with the old one. Okay, and this is the default method of deployment. Okay, getting it? What do you mean by rolling update? So you take one at a time. Clear?
Yeah. Yes.
Okay. Now, in Kubernetes, what Kubernetes supports is only two type. One is recreate, the other one is default, which is rolling update. Okay. However, there are other two types of deployments that we are going to see, which is not a straightforward solution which Kubernetes is going to support. Like recreate or rolling update, we do not have an option for the next type, but it's more about using any one of the deployment type, and on top of it, how do you manage the deployment is what we are going to see as a new strategy, which means we don't have a type called strategy and whatever we are going to see next, but it should be either the default rolling update or it's going to be recreate. But on top of it, how is that you're going to do some additional management by yourself, which will help you to define a strategy. Okay, so that way the next type is what we call it as blue green. Okay, so what do you mean by blue green? Now, ideally, in some cases, what will happen? I cannot try to recreate everything together, or I cannot even allow to slowly do a rolling update, because if my application is such a way that only when all the replicas are up, I will be able to access. Okay, now in that kind of scenarios, you cannot go with either rolling update or recreate. Then other method which we have is called as blue green. So what do you mean by blue green? Now, for a minute, forget about blue green, but think of this as two set of object that you have to use, where assume that you have deployed an object like this. Okay, now I have a deployment object and I have a replica. Now for this, we will be creating a service, and a service whip will be there, and this is what the users will be accessing. Now what happens is, in this type of deployment, now we have to make sure that our downtime, when I say downtime, the time that we take to deploy our new build and switch the traffic from the old one to new one, so that customers doesn't have any impact. That is what we call it as deployment downtime. Okay, now if you go to recreate as well as rolling update, there will be definitely some downtime, because when it is trying to switch and replace all the old pod with the new port, then the traffic handling will be difficult, so you have to wait until some time. Now instead of that, in this method what we will do, customers will be still accessing the service whip, and they will be using the old version of your application or your pod, because as a user, I don't care about the pod. I just have to access the endpoint URL, whatever the whip is giving. So the URL whatever you get, right, that's what we generally call it as endpoint. So the endpoint URL, if I access, I'll be accessing the application. Okay, now while the old version is still running and being accessed, what we will do is we will go ahead and create a new object with new set of build images or replicas with it. Okay, so that way, unlike recreate or rolling update, we will not update the same object. Okay, so instead what we will do now, we will create a new deployment object, and that will be based on the new build image or the version that you want, and accordingly new replicas will be available. Okay, so here you are creating another deployment object completely, just an example. Okay, so at any point of time now, if you see in your cluster, you will have two copies of your application, one which is working, or this has the replica of your old build version, whereas there is another copy which has the new build image or the new build version. Okay, so ideally no one will be saying as a image, you will be just saying, okay, this deployment will have replicas based on your new version or the new build. Okay, then here when you try to create, it doesn't matter for me whether this is creating in a recreate method or a rolling update, because it's a fresh or it's a new object that I am creating. Okay, so for me it's all the time that it takes to come up. And once this comes up and all the containers are up and running, then the only thing that we have to do is we have to cut the traffic. Instead of going to the old deployment object, you just have to switch the service to point to this. Okay, so how will that happen? Now that is where, how is this service referring to this deployment object? So if you go back to the definition of service, we use a label, right? So assume in this, if you go back and refer, I had applied this object by giving a label called Nginx 1.10 or version 1.10. So that is the label what I have defined in my service, saying you apply to any pods which has a label called Nginx 1.10 or version 1.10. So that way these two pods had it, so the service was always going to refer here. Now what we have to do is, when we create this new pods or new object, here we will be using a different version of the label. Say, let's say I will say version is 1.11, which is my label, and we will go back to the service, and now to the service definition whatever we have, we will update it here, so that now in this service, if I update instead of 1.10 label, if I say 1.11 label, then it will not start referring here, it will just start referring everything over here. It is what we call it as switching the traffic. Okay, so now what will happen, as soon as I say service apply and I will say 1.11 as my label, then service will be checking which pod has the label 1.11, which is nothing but this. So it will be kind of diverting your access or traffic here, so that now when you access your VIP, you will be accessing the new version or the new build. So this way of switching your VIP or the endpoint URL from one old build to the new build is what we call it as blue-green deployment. And as the name says, blue-green is nothing but two copies of your object at any point of time, or two copies of your application running. So I'm not talking about these are replicas, I'm talking about these two new objects. So that is where you can consider one version that you have as blue and the other version that you have as green. So now assume I was working on the green version. Now I deployed a blue version, just a name, and here we started using the new version called 1.11. So assume next, after some time, you have to again do a deployment. Then what will I do? I will try to create a new green version in which I will put, let's say, version 1.12. And when everything is fine and my pods are coming up, I'll go back here and just change the label and apply. Then what it will do? it'll just switch the traffic to this. So this is how, in this method, any point of time you will have two complete sets of the object, and you just switch the service to refer to whatever the object that you want. So such a kind of method where we are switching everything is what we call it as blue green. So blue green is just the name given to each copy. So you will know, oh, I'm using currently this green version, I'm using blue version. So that is how they refer. Okay. So now, if you understand, this is one of the type where your actual rollout, when I say rollout, you're doing a deployment, is very, very fast. Correct? Why? Because I am not trying to create anything and I'm not trying to distribute the traffic in between. So my customers will be still accessing the old one, and I'll safely bring up new object, new pods or replicas under it. And when everything is coming up, all I will do is switch the service so that immediately it will start accessing the new one. Correct? So this way it will be fast because it's all about switching the service or changing the service whip to point to new pods. Okay, these are the advantage. Now this is what we are going to do in productions, but the disadvantages with this is it requires double the resources, right? Because now, instead of maintaining my cluster to create two replicas, now I need to have enough space to make sure that I have four replicas. Correct? So this is one of the disadvantages because you need double the resources to manage everything. However, you also have to make sure that before you switch the service to point to the new set of pods or the new object, you need to make sure you are doing thorough testing. Okay, so this is some of the disadvantages that we are going to have. But again, for certain applications, this is something which is quite useful. Okay, so that way we can make sure the downtime. So that's where we need to understand, are you more interested about the time to make it zero downtime? Then you go ahead, because it might require double the resources, but you can switch it out whenever you want, right? And it's going to be instance and the customers will not be seeing any impact heavily. Whereas if you go with the other type, then there will be a downtime which is going to be causing issues. Okay. Now, to understand what we'll do, let's try to run the same. Okay. So now you can see, let me go back to my build one. Okay, let's delete this first. Okay, so now assume that I'm going to set up my first environment, which could be blue or which could be green. Okay, so here I'll apply this to blue.yaml. Okay, so all I'm doing is, okay, take two replicas and I have an image of 1.10 and the label that I'm giving is Nginx and version 1.10. Okay, so that's absolutely fine. And accordingly, now here, build one SVC. Okay, I'll just call it as BG, blue green SVC dot YAML. And here you can see that I'm using the selectors as name is Nginx and version is 1.10. Okay, so again, it's the first deployment, so it doesn't matter for us whether it's doing it in the default rolling update. So here, if I go back and say kubectl apply -f and let's say blue.yaml, and I'll just go ahead and say the SVC. Okay, now because of this, if you say kubectl get pods, you'll have 2 pods running, and the same way you'll have here. And in this, if you just say HTTP and your IP of your VIP, okay, now this is what we have. All right, now assume that the customers are accessing this. So whenever they use their URL or the endpoint URL, they will be accessing the old one. So now in your blue-green deployment, when assume that I have a new build to be deployed, I will not tamper anything with my existing object. So what we will do is we will try to create a new object or a new YAML definition. Okay, so that's where exactly similar to your blue, we will create a new definition called green. And here, if you see, everything is the same other than the version label, which is different, and accordingly I'm just changing the image name so that it refers to the new object. And see, the name of the object is also different. Now I'm not changing anything related to service. The only thing that we will do is kubectl apply -f green. Okay, so here if you go back and say get pods, okay, probably screen is too big. Okay, so here you can see we have 2 pods running with the new replica. So this is what is our green deployment object, whereas this one is blue. However, what we did, I didn't tamper anything to my existing blue environment or blue object, because still if the customer is accessing, assume that they're still accessing the old one. Why? The service is still pointing to the old replicas or object. Now, when you have your new deployment object and the pods has been successfully coming up, the only thing that we are going to do is define your service to refer to the new replicas or the new environment. So that's where now all you're going to do, edit your service. Okay, and in the service, now I'll just change the labels here. Okay, this is the label on the selector. So instead of version 1.10, I will say version 1.11. Okay, so watch this. This is the only change I did. And now if I go ahead and say kubectl apply -f, and it's just this change. Now as soon as I apply, and if you go back to your same VIP and you start accessing, you can see now the VIP started referring to your new set of pods, which is our green pods. So that way in the green, what you have is 1.11. Okay, now you could see the only time that we took was referring my VIP from the old one to the new one. But as a customer, when he's trying to access, there will be a small glitch, but other than that, it will not be a big impact on your downtime. Okay, so that it will be instance. So this is where your deployment time, you will not be making it exactly 0 downtime, but you can see it's going to be super fast and there is not much impact to your customer. Okay, that is one of the biggest advantage. And what if you want to roll back? Understand roll back. Now, we had an option which we had seen in the deployments where we can roll back. But if you do in production, I cannot just wait for my current pods to go down and then recreate the old pods in a rolling update method. So that is where now, if I say roll back, what do you mean by roll back? instead of referring to 1.11, I want to go back to 1.10. So that way, we still have our old pods running, correct? So now if I find any issue in the testing or after I deployed, if I find some concerns where I have to roll back, all you have to do is once again, go back to your service, okay, and then change it the old label or the old version and go back and apply. And now if you access, you will be accessing the old one. So how fast was the rollback? Again, it was instantly, correct? So that's where here the deployment or rollout means you're changing your old version to the new version. That is what is actually we call it as the deployment. So the rollout or the rollback will be very fast. Okay, so that's why this is one of the preferred way of doing it in production. Again, this depends on your nature of the product and how you want to manage. Okay, so when you have certain scenarios where you cannot allow to do a rolling update to change one by one, then you go with blue green, where you have everything available but as 2 copies, so that you can just switch between the traffic or the service and choose which one you want to work, whether you want to work on the blue environment or green environment. Okay, so this is how we will be switching. And now I'm using the green version, correct? Now later, let's say someone comes up with next build, which is 1.12, then now I'm using green, then I will go to the blue one, and in the blue, I'll be typically modifying the image name and then apply and then change this service over here. So that's where it's just only the service switch that you do. Okay, getting it on what do you mean by blue green?
Yeah.
Okay, again, if you have seen, we didn't worry about the type of strategy, right? Because whenever we are creating, it just tries to create by default using rolling update. So we took rolling update here, but on top of that, we try to deploy by having 2 set by just switching. So this method again is not something which Kubernetes handles. We had to manage on top of the default strategy, which is rolling update. Okay. Now, similar to this, there is another method what we use, okay, which is called as canary. Okay, now what do you mean by canary? So canary is what we call it as one step at a time. So there will be certain projects where you can divide them into smaller and smaller components, and now instead of releasing everything together, you can release a subset of your product and then try to replace. So that way, it is somewhat similar to what you saw in rolling update, but the difference was in the rolling update, you had the same object, and inside this object, the old pod was replaced with a new pod, right? But however, in the canary, you're going to have a new object, and in the new object, you're going to replace the old pod with the new pod. So that is where in theoretically, if you take in canary, you're going to take subset of your product or your component, and you're going to kind of roll out one component at a time. Okay, so to demonstrate that, just have a look at the diagram so that you will see the difference between rolling update and the canary. So in the canary, I'm going to replace my old pods with the new pods. That is what I have to do. But instead of updating the same object, we are going to create a new object where you need to first bring the first replica in your new object. Okay, so then once this comes up, you are going to then add this to your existing service. So that way, now As a customer, they will access the old pods as well as the new pods. But when you are creating a new replica, corresponding old replica should be removed. So this is how any point of time you will be having the same replicas available. But you can see customers can access these two old replicas, plus there is a new replica which will have a new subset of component, whatever they need. Okay, so that's how you are going to replace everything one by one. Then same way, now we will take the second replica and make sure that in the new deployment you have the new build image out of which it is coming, and then you will be just changing your first pod. Okay, so this way, where you take a subset and you try to deploy one by one, is what we call it as canary. Okay, so you can think of it in a simple difference is, in rolling update, in the same object you are updating, whereas here you're trying to define a new object and we are trying to replace the replicas one by one. Okay, so that's where again this method is very suitable when there are certain products where instead of releasing the entire product or deploying the entire product, you're going to take one by one slowly. Okay, now this is more convenient because here you can easily switch back, or the rollback will be happening because you are not deploying the entire product. You are just trying to take one at a time, correct? So that you just have a subset of the component and then you start accessing. But the problem is it's going to be again very slow, right? Just like rolling update, if I have too many replicas, then it's going to be too difficult for us to do the release, where taking subset and doing one by one will be little difficult. Okay, and at the same time, if the traffic control has to be done, then again it's going to be little difficult because you need to have too much of networking to be done so that you choose where should be the exact traffic going into. Okay, again, for certain products canary is also suitable. Okay, however, remember, in canary, once again, Kubernetes doesn't support anything directly because it supports only recreate or rolling update. But now on top of it, we are going to handle just like how we had blue green. Okay, so now what is that we are going to do in canary? So you're going to have one object with replicas. Now what we are going to do, we are going to create a new object where you need to first create one replica on the new one, and corresponding to it you have to go back and shut down one replica on the old one, and then create the second one here and correspondingly shut down the old second one. So we have to do a balance of one by one. Okay, which is kind of time consuming. Now let's try to do this. So to show you this example, now look at this, where what I'm going to do now, I'm not just trying to have the versions. Okay, so I'm just trying to have typically the same label for all the objects. So that is where I'm using only one label, and the name of it is, or the label is name Nginx. And typically, just as I showed in the example in the diagram, I'm going to take 3 replicas, and my service is also going to refer to only one label, which is name Nginx. Okay, so if you go back, so just to show you this, what I'll do, I'll call this as canary. Okay, cbuild 1. So over here, if you start comparing with the objects that we have created so far, the only change here is I'm not defining two labels. So there's only one label called name Nginx, and first I'm trying to say Nginx 1.10. Okay, so let's go ahead and apply this. Okay. Is invalid. What was invalid? The deployment Nginx hyphen is invalid. Okay, somewhere.
Is it a colon there? Nginx in the metadata name, Nginx colon 1.10. We gave Nginx hyphen 1.10, right? Is that right?
Yeah, that's correct. Copy paste sometime. Let's just cross check. That's the reason I copy paste. But still, spec. Okay, replicas selector, match label, and this template. Everything looks good. Then what's the difference? Okay, let's cross check here. Metadata, Nginx, spec, replicas, selector. Is there any spelling mistake on match labels? No. And metadata. Okay, let's do one thing. Probably I'll copy this and I'll paste it here. And we'll just remove few things. Let me remove this. Let me remove version over here, version over here, and let's make this 1.10. Okay, deployment Nginx. Okay, this looks good somewhere, some space or some indentation somewhere. Okay, anyway, let's not worry, let's take this itself. It says why? Name Nginx, label is Nginx. Label selector, field is okay. Spec.selector, invat value. Match label string name Nginx. Is it expecting the service to be available? Okay, probably. I don't think. VI canary as we see. That's not correct. Okay, somewhere some wrong. Deployment 1.10 is invalid. Label selector match labels string. Okay, this is a string. Now what's the problem with this? Anyone see the difference? It's the same. Okay, I have okay, probably I'll just call it as deployment name. It could be an issue. So I'm just changing the label to deployment name. Okay. And let's try this. There's a problem with the name. Because here also you have a name. Let's say something issue with this. D and label over here. Okay. So this is my pod label and this is my deployment label. No, still. And what's the issue? Spec.selector. Okay. In the selector, it says it's here. This is selector. How come it's wrong? It says selector is wrong. Okay, let's understand what's the error. Spec.selector invad value v1 label selector. Okay, match labels. It should be a map string. Oh, vi. True, not even this. Okay, label selector requirement is nil. Something is fishy. No, I'm not. See build. Then how come it worked so far? Am I missing something? Selector, match label. Okay. What else is wrong? Okay, selector, replicas selector, match labels. Then how come it worked fine earlier? Okay, one last try. Let me debug later, but I'll just take the build one and I'll copy this to build one. Okay, this is what I have. So when I say kubectl apply fnf c build one, this works fine. Okay, let's do one thing. Let me just kubectl delete. Okay, if I just comment this. What did I do? Nothing. Cat c build.
There might be some typo.
Sorry, I didn't get you.
There might be some typo in YAML file.
Yeah,
Like
that is what
space.
I was thinking. So what's the difference between this and this now? There's nothing. Okay, let me just remove this. Okay, I don't know, probably some issue. Let's see if this is working.
Aram, do you suspect there might be some bug in somewhere, Kubernetes?
Not Kubernetes. It worked fine for another example. It's just about copy pasting somewhere. So let me just delete and try to confirm it. Okay, I'll rmc build one. I'll create a new. Okay, sometimes it happens. That's where just always have a previous reference. Okay, so yeah, now let's just make it 3 replicas. kubectl apply fnf c build. Okay, never mind. First thing I should do is copy paste. Okay, might be some issue somewhere, some indentation or some characters. Anyway, I'll just okay. These are the changes.
Yeah, Adam, previously we used to give that image name in the containers.
Oh, did I do anything wrong there? Even I didn't see the version.
Can you go back to that notepad?
No, I just now changed it.
Okay. In the containers image name after image nginx -1.10.
Oh shit! Yes, this
Previously
one.
we gave.
My goodness.
Yes.
That's what I was wondering. Like, why is it giving me error here? Okay, so this was the problem. Anyway, thank you. Yeah, debugging. So anyway, coming back, we didn't even deploy anything. Fine. So here, kubectl get pods. Okay, and do we have the service created? Yeah. I have my service created where this is where I have my service. Okay, fine. So now in this, what we did is just that we deployed 3 replicas of our object. We didn't do anything else, right? Now, in order for us to do the canary, let's first check once again. Okay, I'll use this one. Okay, kubectl get svc. This is the one. So here, if I say curl-s http version, so you can see I'm accessing 1.10. So that is what is expected because we have 3 replicas and it's working. Now for the canary, now we don't have any method within Kubernetes where it will try to create one replica in the new object and bring down the other one. So that's where it's all about how we handle from our side. So that's where now I will create a new object. Okay, and if you try to compare this with what we have, the only change I'm going to do is the name of the deployment will be new, which is 1.11, and then the replicas I'm making it as 1, and I'm trying to define the image as 1.11. So that way what will happen? Now I will be getting new object called deployment nginx 1.11 with only one replica, and that is also having the same label. So that way when I access my endpoint, it can access anything out of the 4 replicas together. Okay, so that's where what I have to do is I need to first apply, and as soon as this comes successfully, then I have to come back, change this and make this 2 replicas. Okay, so that is how we are going to keep scaling this one up, and we have to scale this down. Okay, that is what we are going to do. So let us just define so that here again it's the same service, we are just trying to scale up and scale down the objects accordingly. So I'll call it as cbuild2.yaml. Okay, so if I go ahead and say kubectl apply -f cbuild2. Okay, so now at any point of time, if you see, you would be having 4 pods, right? And accordingly, if you try to access here, now it would be random access. You can see once it is trying to say 1.10, because out of it, it might access any one of them. Okay, this is where I was talking about the control of the traffic. So it does in more of a round robin fashion. Okay, so now what happens? It will be trying to go through. So now what we did, we just brought one replica which is having new, and the other one what we have is 3 old replicas. So now since the first one in your new object came up successfully, now we have to reduce the other one. Okay, so this way I can go to my YAML file and I can bring it down by changing the replicas and apply. If not, we have our scale command, right, where I can use it directly from the command line or imperative and I can reduce it. Okay, so what is the scale command? Let's go up and search for the scale. Okay, this is what we have. So this is one method of changing it, wherein I can just give everything from command line, but you might not be able to know what has been changed, right? So that way here I can say the label as name is Nginx, and over here I can say deploy. Okay, so this is one method. Now I can change this so that it will be picking up whatever the particular pod or the particular deployment object that you want, and it will be changing. Instead, what I'll do, I'll go to the C build one. Okay, here I'll change this to 2, and we'll apply it again. Okay, so now if I say kubectl get pods, so you should see totally 3, wherein you had 2 old replicas and 1 new replica. Then what should I do? The same way. Now if everything is fine, then I should go to build 2, and here we'll scale up. Okay, so we'll apply. Okay, and now when this comes up fine, okay, go back to your C build one, and here change it to 1 and apply this so that you're balancing it together. That is it. Okay, so now you can see we have 2 new pods with 1 old pod on the previous object. And same way, the last one, now everything is fine. Then go ahead and scale up again to 3. Okay. So we have now 3 new replicas with old replica. So I just here go back and change this also, or simply, now I don't have to do it 0. Now if everything is fine for me, I can just go ahead and delete the previous one. Okay, and let me say C build 1. Get it? So this way you're going to take one at a time, or component by component, or subset of users by users, and then you try to release. So such a kind of deployment method is what we call it as canary. Okay, so that way the rolling update and canary is not something which Kubernetes does straightforward, because internally we are using rolling update only, but it's more about how we manage it on top of it. Okay, so that's where now the default method will always be rolling update. So based on your application and based on your environment where you're trying to deploy, so you need to choose. Okay, so every organization will have their own method of deployment, which is nothing but a strategy that they will be following. Okay, clear so far on the 4 types of deployments? Any question?
Adam, I have a question.
Sorry, didn't get you.
So, what is the difference in like active and blue green? Is it the same thing? Because we are doing the same thing. That's what I assume.
What is it?
What's the difference in active and the blue green? Because in active, we wait for the other cluster to ready, and then
No, I didn't.
Okay, I'll take it.
Active.
Yeah, active.
Probably can you just ping in the chat?
Okay.
I'll
Okay.
just get back. Your voice was not clear.
Okay.
Okay. Sure. So this is where now what we need to know is, it is not just about defining your manifest file and try to say kubectl apply. The method that you have to choose to apply and create the pod is what we call it as deployment strategy or rollout strategy. Okay. So anytime if you're going to any organization, it's quite important for us to make sure that we know how to apply and replace the changes with what we had earlier and the new version, which is what we call it as rollout. Rollout means you're making sure your new version of application is available for the customers to use. At the same time, you should always have a backup plan in which if there is some issue, you should be able to go back to the previous version, which is what we call it as roll back. Okay, so understand this, a small difference. Roll out means you are going to the new version. Roll back means you are going back to the old version in case of any issue. Okay, so that's where based on the application, you have to choose a convenient type. So it is not like this is good or this is bad. Depending on different nature of business, you need to make sure that your downtime is also zero, and at the same time, you also see which is most effective for you, which is cost effective. Okay, so based on that, we have to choose a method. Okay, now this is what we had typically in Kubernetes. But before I proceed further, right, take a small break. I'll stop it for now.
This conference will now be recorded.
Okay, there's one more thing that we need to know. See, as of now, the cluster that what we created, right? So again, that could be a Minikube, or that could be a cluster that you create using Kubedium, which is a raw method, or even if you create a EKS cluster or AKS cluster in Azure, by default, you will be having all access, okay? Because what happens is when you start working, just like Jenkins, if you remember, we had all access to do everything. The same way, in a Kubernetes cluster, whatever that we created, you have by default all the access, because that is where for our practice also, we were able to create all the objects that we want, delete it, update it, right? Everything that can be done. But when you go to a production grade cluster, what happens? Now, if you start having a full administration credentials where if you are managing certain things, then you don't want other users to have full access. So that is where ideally what we have to do is ensure that we need to have different kind of roles for people who are going to work. Okay, it's just for illustration where I'm just giving 3 types of people or 3 types of access that you need, where assume if it's more from someone from the product team, like a developer. So what does he need to do? So he doesn't need access to modify certain things, or let's say there is an object where he just have to see it, right? Then he needs to have access only to certain APIs of your Kubernetes, or he should be able to internally run only certain commands because they will be talking to certain API and return some values. So that way, developer needs to have only read access. Now, what is an operator? Now, operator are those where you will need to do some automation. So that is where, as a DevOps engineer, you might have to do some operation or automate certain things where using that automation, you will be able to deploy or apply some changes which is needed. So that's where now for those, you need access to create an object or delete an object or apply or modify an existing object. So that kind of access that you might need, but you might not have control completely on your cluster administration. Like, I don't want someone who is being an operator to create a new persistent volume object because that requires to communicate to AWS and create. However, the operator should be able to define the persistent volume claim and use in the pool of persistent volume object. So that way, now I have to restrict. Then I might have to have a separate role called operator, and whoever going to work, I need to give that access to them. And administrator, again, it's someone who needs the complete administration privilege on the cluster where they can do everything. So that's where, how do we ensure all this? Because the one that we were working so far, you are actually having the complete admin access. This is what I meant by using the kubeconfig file, because whenever you now try to run the kubectl command, it will be reading a config file called kubeconfig, which is what, if you remember, I copied it from the root user and I had pasted it into the Ubuntu user on our actual cluster. And in that, if you have noted, there was something called as a service account and it mentioned Kubernetes admin. So that way, whatever that you are running so far, you're running as a default admin. That's the reason you had complete access. But however, in a production level or a production gate cluster, we need to make sure that we define some kind of access control by which I can say, if you work, what kind of role that you want to work, and based on that I can give only specific access to you. Okay, so such a kind of concept is what we call it as RBAC, or in Kubernetes 1.8 this new concept of RBAC was introduced, which refers to role-based access control. Okay, now what do you mean by role-based? So what you're going to do is you are going to now give certain access to a person, and that's what we call it as role. Okay, so role is like you will be an individual, but depending on what kind of access that has been attached to a role, you will be able to use them. Okay, so internally for this, Kubernetes uses a specific API. Okay, now as we move on, anytime that you see any production level that you have to maintain a cluster, the first thing what we have to do is enable this RBAC. Okay, so it's not just you create cluster and start working, but you also have to make sure that you enable the role-based access control. Only then in that, what role has been given to you, based on that you will be able to work on some options. Okay, so to see that, let us first understand in RBAC what are the concepts that we have. Now typically in RBAC there are three major keywords or three elements of RBAC. Okay, so they are called as resources, subjects, and verbs. Okay, now what do you mean by resource? So resource is nothing but the objects that we have been creating so far, are the APIs using which we will be managing certain objects in the cluster. So your pod, your service, your deployment, right? All of them are what we call it as resources. Then subjects. So that is what we are going to see new, where subject is nothing but a particular user or a group of users against which we are going to manage the role-based access. Okay, now typically this is where what we call it as a service account will be created. Okay, wherein a service account can be pointing to a particular person who wants to manage, or it could be more of an account which is used by a group of people to do some task. Okay, so that way, now the next part is subject, which is referring to a service account or a user who is going to access these resources. And then the next one is verbs. So verbs are nothing but the operations that you want to run or execute against this resource. Now let's just take an example of pod. So what are the actions that you can perform against this resource? You can say create, apply, right? And then you can delete it, you can get pods, you can describe pods, right? So these are the actions that you do, which is what we call it as verbs. Now with the combination of these three, we will be able to specify how access can be given on role or based on role. Okay, so that is with the combination of your resources, subject, and verb, we will be able to give the access. Okay, now how? Watch this. So when we try to work on this RBAC method, the first thing that we need to know is whatever the role that you are trying to define will be specific to a namespace only. Okay, however, we can also specify whether you want to give a role only to the objects under a namespace, or you want to apply it to all the namespaces under your cluster. Okay, so that way, now for implementing your RBAC, there are two things that we need to use. One is roles and role binding. Okay, wherein role is nothing but API which will help you to specify certain access for a given namespace or for the entire cluster level. Okay, so it can be a role for a namespace, or it can be a role for your entire cluster. So that is what is the difference. Okay, now when you take a namespace, now here we have our resources and we have verbs, right? So that is what I just told you before. So my resources are nothing but these. However, what are my verbs? Or these kind of actions or commands that I can run. Now, a role is nothing but, it is a combination of these two together is what I call it as a role. So now if I'm giving or creating a developer role, so I have to define, okay, I'm creating a role called developer role that will be applied only to pod, just an example, or service. And here I will say only get. Okay, that means if you are using this role called developer, then you will be able to run the get command against a pod and service. So like way, you are going to create multiple roles which will tell the combination of what resources you are going to use, and against it, what are the verbs or commands that you're going to apply or allowed. So this is how you are going to define a role, which will be a combination of resources and the actions or the verbs that you're going to take. Now, in that, the next step, what we are going to do is called as role binding. Okay, so this is where the subjects, whatever I was talking about, which was the third element, right? This is nothing but a service account that we have. So now we are going to tell what is the service account that you're going to use, and for that account, what is the role that you're going to bind. So this way, if you go to your kubeconfig file, you need to specify what is the service account that you're going to use and run your kubectl. So that way, when kubectl tries to access your cluster using this service account, whatever is the role which has been bind to it, based on that, you will be able to access or not access. Okay, so that's how, as we go to production, they will be giving you the access. Okay, so remember, so we have three elements for our access control. One is resources, the next one is our commands, or what we call it as verbs, and then the subjects or the user accounts. So first we need to create role, which specifies which object to use, that is which service to use, and against what actions or commands that I have to run. And then that you're going to apply to a specific user or a service account. And this service account is what you will be defining in your kubeconfig file. Okay, so that way, when you're actually running kubectl command, you will be accessing the cluster's API with the help of this service account. And as I mentioned earlier, whatever the role has been binded to your service account or the user account as whom you are running the kubectl, it will be allowing you only those actions. Okay, so this way you can apply a RBAC to a particular namespace, or you can put the same thing to the entire cluster. Okay, so if you are applying a RBAC or a role for a namespace, then we call it as role and role binding. The same way, if you're trying to apply it to a cluster, then we call it as a cluster role and a cluster role binding. Okay, why? Because these two are objects. So when you're defining in your YAML, you have to define these two also. Okay, getting this? Clear on this part?
Yes, sir.
Okay.
Can you talk about the cluster role one more time? I just missed some of it.
See, you can have an access given to a particular namespace, or I can apply it to the entire cluster. So I can create a role which is not only to one namespace, it will be to the entire cluster. So that I can say, okay, I want to apply a cluster role developer where you take any namespace, you should be able to only get the list of pods or get the list of deployments or whatever services that you want. So that way I can tell to a particular namespace, or I can tell it to a cluster level. But internally, how are you going to define all those things? You need some YAML file in which you are going to write. But when you're trying to write or define, now we know for every object there is a API that you're going to use, a version, right? So in that way, now if you're using the cluster level role and role binding, so the name of the API is what you will be using is cluster role and cluster role binding. Okay, that is what it is. So tomorrow typically I'll take up an example and I'll show you how this will be implemented. At that time, you will see if you see a word somewhere defined as cluster role or cluster role binding, then you're applying this for the entire cluster, not for a particular namespace.
Yes, okay. Thank you.
Okay. So now remember this, because again, if I have to explain you, then it will take time, because tomorrow I'll take up with a different use case, and along with it, I'll try to show. Okay, so that's where tomorrow we'll talk about EFK, Elasticsearch, Fluent, and Kibana. Okay, now wherein we will set up the EFK for our Kubernetes cluster, but when we are setting up that, we need the access control. Okay, so that's where let's get a little deeper into it. So tomorrow I'll talk, but before I go there, I just wanted to give you the overview of how this works. So remember, when you go to production, it's not just Kubernetes. When I say I'll define a YAML with just one object and replica or service, you need to understand how you're going to access, and based on this only, whatever commands that you're trying to run will be executed. And in fact, now if you actually see, when you run your kubectl, right, it will be reading your config file by default. Now this is a Minikube cluster, right? So okay, let's go to the other one so that I can show you. Looks like I deleted. Here, okay, so let's see whether we have this file over here. Okay, so this was the default file. If you go back to Minikube, now every time when you run kubectl apply, it will be referring to this. However, when we created a cluster, so I showed you that copy this file to the user directory or home directory of Ubuntu, which was your default account. Like that in an organization, when you get an account, you will be having a specific kubeconfig in which you will be having a service account defined. So if you just open this, okay, now here you can see that what is the account as which you are trying to run. So here you're just running with the default admin where you have the complete access. Whereas if you go to a production level, this will not be the sample file that you will be applying. Okay, so we need to customize, and here you will be getting a service account, and along with it, you will also be getting an access. So probably tomorrow when I set up the new cluster, I'll show you. Okay, so using that only you will be able to access. Okay, so that is how we will make sure that when you're accessing Kubernetes or your kubectl, you're accessing it using a role which has been defined. Okay, and that role would have been having a role binding, which specifies what kind of access that you want to have. So typically now, since we are going to manage, or if you are going to manage the Kubernetes deployments, then you might get the administrator role, or you might also get an operator role. Now, there is nothing called as an operator role or administrator role in reality, but it's just a name what we can give, which is very clear for people to understand. Okay, I'm an administrator on my cluster, so I need all the privileges for administration, or I'm kind of managing my deployments and helping the automation of deployment, then I need something like an operator role. So that way, operator role will have almost all the access other than some crucial administration task, whereas administration role, you should have every access. Okay, so that's the primary difference. Getting it? So remember, even from interview, if someone asks you, how do you specify roles in your cluster? You just say using RBAC. And this is possible or available only on version 1.8. Okay, so for which you need to create a role, and role depends on what resources that you're going to apply and what actions or verbs that you're going to use against it. And that you're going to bind to a subject or a user or a service account. Okay, that's what we meant by role and role binding. Now, role and role binding is more for a particular namespace, but if you're applying to the entire cluster, then you're going to call it as a cluster role and cluster role binding. Getting it?
Yeah. Hi, Adam.
Yes.
Roles are binded to a subject, and the subject are defined in admin.config.
Yeah, not exactly in that. So it's what we call it as kubeconfig.
Yeah, kubeconfig. Okay. But API resource and barbs, the role we make by a YAML file will define the role.
Correct.
Okay. The role binding also happen in cluster level and also namespace level.
It depends. If you say a cluster role binding, then the binding happens to the entire cluster. If you just say role binding, then whatever the namespace to which you have defined, the binding happens only to that. Okay, so it's based on your definition how you tell that.